Morning to all. I am Niveta from Konganadu College of Engineering and Technology. Today we are going to see the topic about acid properties in DBMS. That means acid properties in DBMS. In the context of transaction is processing, the acronym ACID refers to the four key properties of a transaction. That means ACID. A means atomicity, C consistency, I for isolation, and D for durability. All the changes to data are performed as if they are single operation. Okay. Each and every transaction, the acid properties are followed. First one is atomicity. Each transaction must be considered as a single unit and must be completed fully or not completed at all. If the transaction is completed or not completed at all, database should be in a state either before the transaction execution or after the transaction execution. In a transaction involving two or more discrete pieces of information, either all the pieces are committed or none at all. The term atomicity defines the data remains atomic. It means if any operation is performed on the data, either it should be performed or executed completely, okay, or should not be executed at all. It further means that the operation should not break in between or execute partially. The second is consistency. The database must remain in a consistent state after performing any transaction. Okay. Isolation means a transaction in a process and not yet committed must remain isolated from any other transaction. Data is in a consistent state when a transaction starts and when it ends. For example, in an application that transfers funds from one account to another account, the consistency property ensures that the total value of funds in both the accounts in the same at the start and the end of the each transaction. For example, if you are having the transaction 1 and then transaction 2 means if you are transferring the amount to first transaction, that means account 1 into and then account 2. The consistency property ensures that the total value of funds. For example, if you are having the first transaction having 100 rupees amounts means each and every, the second transaction must having the that same amount, that 100 rupees. Okay, at the start and end of each transaction having the same amount. The next one is isolation. For every pair of transaction, one transaction should start execution only when the other transaction finished the execution. Here, for the example, the transaction 1 is T, the second transaction, the first transaction fully completed. That means completed means the transaction read and write operations are performed. Um, in the transaction 1, we are having the read X. Read X means for reading the value of X from the database and then finally process the X value. X is equal to X star 100 and then write the X value. If you are having in the X is 100 means 100 into 100. Okay, and then read Y, the next values, and then Y is equal to Y minus 50 and then write the Y operation. In the transaction 2, read the X value and then read the Y value and then perform the operation Z is equal to X plus Y and then write the Z operation. For every pair of transaction, one transaction should start execution only when the other transaction is finished. The isolation means, the term isolation means separation. In a DBMS, isolation is the property of the database where no data should affect the other one, okay, and may occur concurrently. In short, the operation on one database should begin when the operation on the first database gets complete. Okay. The next one is durability. Once a transaction completes successfully, the changes it has made into the database should be permanent, even if there is a system failure. If the system failure happens after the customer getting the money, then the system should be strong enough to update the database with his new balance after the system recovers. This property ensures that once the transaction has completed the execution, the updates and modifications, okay, the updates and the modifications to the database are stored in it's a stored and they are written to the disk, and they persist even if a system is failure occurs. These updates are now become permanent and are stored in a non-volatile memory. Okay, the system failure is happens after the customer getting the money, then the system should be strong enough to update the database with this new balance after the system recovers. Okay, it's a committed data is saved by the system such that even if the event of a failure system restart, the data is available, it's a correct state. These are all the four properties in a DBMS: that atomicity, consistency, third one is isolation, and then durability. Okay, this is the transaction states. There are 5 states in a transaction. First one is active, then partially committed, finally committed. If the transaction is failure means finally about the transaction. Okay, the active means insertion, deletion, or updation of record is done here, but the data is not saved into the database. So it's always in a buffer. It's the active mode. Insertion, deletion, or updation of record is done here, but the data is not saved to the database. Partially committed, when the transaction is executed, it's a final operation, that is a partially committed. And then failed means if any of the checks made by the database recovery system fails, means a failed transaction can no longer proceed further. In this state is called failed. And then aborted. If a transaction is failure to execute, then the database recovery system will make sure that the database is in its previous consistent state. If not, it brings to the database is a consistent state by aborting or roll back to the transaction. Committed, if the transaction executes all its operation successfully. Okay, each and every transaction should perform the ACID properties and then these levels of transaction states. For example, transaction, you are having the transaction 1 and then this one is the transaction 2. In first transaction, read A from the database. Read the value of A from the database and then performing the A is equal to A plus 50 and then write A operation. Next transaction is started, read A. Here the A values, first A value is 100 and then this transaction A plus 50 means A having the value of 150. Here A is equal to 150. After A is equal to performing the operation, A is equal to A plus 100. Then 150 plus 100 is equal to A is equal to 250. Okay. Before going to this write operation, these performed rollback operation. A is equal to 100. Restore back to the original value, which is before transaction T1. Finally, we write the transaction 2 of A operation.